Well, welcome everybody to our next WestGrid town hall. We've just got a few admin details, so I'll get started right away, and then as people come in, we'll get into the nitty-gritty. Anyhow, let's just look at the admin details here. So we're going through this. There's a hand icon on the video bar down at the bottom, and if you want to ask questions during the talk, then just click on the bar and we'll try to answer the questions there. And of course, always a good idea to mute yourself due to background noise and such, unless you've actually got a question to ask. For this talk, this town hall, we've got quite a bit of stuff to go on. We're going to talk about the new systems a bit, some of the issues, go through all the stuff that's coming up, migration, the RAC 2018, some user training in future systems. But what's really nice is that the new GP4 system is going to come online sometime next year, and the teams are in the planning stages. So we've got Greg Newby, the Compute Canada CTO, attending, and for the second half of this town hall, he'll talk a little bit about GP4 or some of the very preliminary plans, and then hopefully we'll get some input about what those folks who are on the call would be interested in seeing on such a new big general purpose system. So that's I think that's kind of exciting that we'll do some of that.
Just another quick housekeeping note. If people want to ask questions and you're watching the web stream, you can also email info@westgrid.ca. And for those who are watching the video feed, if you double-click the slide view, it'll actually open a new window, and you can enlarge the slides to see any of the smaller details. So,
cool. Thanks, Aaron. Yeah, okay. And I'm Patrick Mann. I'm the Director of Operations for WestGrid. So let me go right into new systems and such. And I think it's been a really exciting summer. Cedar and Graham, the two big new general purpose machines at SFU and Waterloo, are up and running. They've been in operation since sort of early July, and sort of in production, I think, in a more or less stable state a bit after that. So that's been kind of wonderful news, and we've certainly seen usage ramping right up. They're well used already. And a couple of notes there that that Cedar, there's a big storage and compute expansion in progress. In fact, it'll probably double in size. And I've got a bit more about that. In Graham, too, there's a storage expansion. And then just to note that the large parallel system in Toronto, the Niagara system, that's in the final stage of negotiations with vendors, 60,000 cores. So we'll be expecting to allocate that system during the resource allocation competition in 2018. So there's so exciting things ahead of us and exciting things behind us that we've actually got these systems going. And then a few more really interesting updates here, I think. Arbutus, that's the Compute Canada Cloud at University of Victoria, going strong. It's being used for both persistent portals and platforms, and also for straight compute with things like high energy physics guys and the Atlas guys. There's a 100 gig network connection to it, and one of the things that it's definitely short of is storage. That's the Ceph storage system for block file storage. So that's going to be increase from about 1.5 petabytes now to about 3.5. Might be before Christmas, but somewhere in that time scale. And we're going to add a few more cores to it. In fact, quite a few more cores. So again, great news there. And also, the other general purpose systems all have, were all originally designed to have some cloud partitions. So the Graham, the Waterloo one's up and running, and I think just for the last couple of weeks. And I think we've got 1 or 2 users on that already. And the Cedar cloud partition isn't quite running yet. Should be pretty soon, and you can see the details there. They're kind of elastic partitions. One could expand the clouds when, if necessary, if demand warrants it. So again, kind of neat there, and it opens up the whole thing to access to the very large storage systems at Cedar and Graham, the 10 petabyte storage systems, and allows us to start really thinking about geo-replication and reliable cloud stuff. So if you're interested in that kind of thing, please get in touch with us. Just one note, that little note right at the bottom, the resource allocation competition, the RAC 2018, next year's, we're only asking people to define a generic cloud. If you're already on something like Arbutus, you should probably mention it. And if you really do want to try some geo-replication, that kind of thing, then we'd really like to know about it, and you could mention it explicitly in the RAC proposals. So some cool stuff happening there. And then the data. Yeah, okay, so we've got the big data, the project file space at Cedar and Graham. I'll have a bit more to say about the nearline space. The object store is indeed delayed, having some issues with the DDN, Data Direct Networks, WAS product, which we purchased. And so we've got quite a lot of demand. A lot of platforms and portals are very interested in that kind of object storage. But we're delayed at the moment and working feverishly on getting it up and running. Yeah, still needs quite a bit of work, I think. Yeah, okay, so there's the basic approach and things going well. I want to, at this point, just delve into a few of the known issues that we've got with the systems. So the storage, that nearline, yeah, that's a little bit of a problem. I think essentially when we put all our effort into getting Cedar and Graham up and running in the cloud, the nearline end languished a bit. We didn't get around to really getting it going, so it's not yet available. We did allocate nearline that, and just to remind everyone, you know, nearline is essentially tape only, a way of moving or archiving data into a separate cache, and then it could be moved straight to tape. So it's a tape system. So right now, if you do have a RAC 2017, this year nearline allocation, then you can ask, and we can, on request, give you some space on the disk/project system. Yeah, lots of fun things going on with nearline. I think that's turned out to be a rather more complicated thing. It sounds relatively straightforward, but then you get into when you can do it, HSM, how big the cache is, where the tape drives are, the fact that our major project file systems are really big, and some of the standard approaches really don't scale to those kinds of sizes. So there's some nice stuff going on, but I think we've got months yet before we may have the nearline end. So yeah, so if you need it and you got allocated, give us a call, the usual support at WestGrid, and we can help you out. A minor little detail, that number 2, the project space. Yeah, that started off getting everything up and running back in July, and with a very simple project architecture, and that was switched to a group-based architecture. And remember, allocations are given to a group run by a PI, and this approach with space in a group subdirectory with the group members within that subdirectory allows for keeping track of all the group members and who has access to what and sharing, all that kind of thing. The details are on the Compute Canada Docs wiki, and I think there have been a little confusion of that, not too much, a few tickets about how to share, where the links are, where to see that. So again, have a look at the project layout, and if you're trying to share within your group or within users, then you can give us a call to the support email. So yeah, okay. So storage, scheduling is always a pain. I think probably every town hall I have noted that scheduling is always a big compromise, a balance. We've got large fat nodes. We've got users with short jobs. We've got users with 10-day jobs. We've got nodes with GPUs. We've got two kinds of GPUs, fat nodes and thin nodes. All of these, the scheduler has to handle and figure out where it's going to put things and where it's going to fit jobs in. So we had a few issues there. They got reported pretty early on, actually, that some users were noting that that they weren't getting some resources, and there were some issues then with users with small, short jobs who were managing to fit into the available holes in the system, the free nodes, and that ended up penalizing default users. So these guys ended up taking everything and not leaving enough space. So there's a new configuration, but it's quite a major reconfiguration of the Slurm scheduling configuration. So we're going to wait for a major cluster update to implement that, because it'll stop all the existing jobs. I thought that
might have wanted to say something. Martin, did you want to say something?
No.
No? Okay.
Yeah, thanks. Yeah. So we'll wait for that. We kind of thought that that might have happened by now, but we're waiting for some parts for Cedar that need to come in, and then there'll be a significant downtime, a day or so, when all these bits and pieces get done. So keep an eye on that. We'll be announcing that, of course. Secondly, there were some issues with large groups who had many members in the team compared to groups with fewer members, and they were not getting their fair share from the RAC. Again, due to some little details from the scheduler. So there is a new fair share configuration, and I think that's actually been implemented this week. So we should see a few changes that. Most of you won't see much of a change there. And then the final point, there do seem to be a few spare nodes which are essentially waiting around, so the scheduler can group them in preparation for a large job. So okay, those nodes sit around not doing anything, and the scheduler can backfill those. It can look for small and short jobs that will fit in the time it takes until the next big job is running. So anyhow, yeah, there's a few holes there to fill. So if you got small and short jobs, go for it. They're good things to submit. And I note down the bottom left there, Camille from Marcinkowski from U of A is the lead of the national scheduling team, and he's been giving some courses, and he's giving a course on October 24th. I'd really recommend that. As usual, one of our major ticket or issue reporting stuff is that folks feel that their jobs take too long to run, they're not getting the resources they want, that kind of thing. And it's really good to know how the scheduler works and how you can play with it, and how you can optimize your jobs to get what they need. I know Camille also gave one at SharkNet in Compute Ontario, and there's a link there to the SharkNet notes as well. So how are we doing? Any questions? We're good right now? Yeah. I think I mentioned one of these before, but the software for both Cedar and Graham have been centralized through the CVMFS. I can't remember what it stands for. File system. It's a shared file system, and both Cedar and Graham use that file system to load up all the software. And the Research Support National team installs the software at a central location, and then it distributes out. That is great. Everything looks the same. Cedar and Graham are consistent. However, there are some issues because the base libraries and apps, some of that stuff still comes with the operating system. So sometimes the build systems for your own software that you're really interested in, unique software, things like CMake or AutoConf for any of the build systems, can get a little mixed up. So if you do find issues with building your own stuff, then again ask support. There are some slightly nasty little tweaks involved there. And then finally, the visualization interactive nodes are not yet available. You can still do visualization, see the training sessions, but not directly on an interactive node. That'll come soon. Yeah, and I think that's about it for the known issues. So not too bad. Keep reporting them. We still expect minor details to appear on the systems and tell us what's going on, and we'll work with them. This is kind of a left field little slide. Just thought I'd include it for a little bit of fun. The Compute Canada tickets, and that you can see in the purple on the right-hand side. Come July or so, we started getting lots and lots of tickets about Cedar and Graham, and it really booted right up. So yes, we got lots of questions. That's great. The usage really came in. We got a lot of users. So great stuff. Keep asking questions, and we can see that usage really building up. Right, I want to talk a little bit about WestGrid defunded systems. That's the old systems, the legacy systems. Here's the existing end. Both the 3 machines here have all been defunded, and as far as I know, the local institutions are going to keep these systems running. So feel free to talk to your local IT services. The email addresses are at the bottom there if you want to continue using these guys. SFU is expected, the Bugaboo system is going to go December 31st. I got a couple of notes about that. And then at the end of March, there go the rest of our systems. Yeah, so we'll be sending out more stuff. There are the WestGrid detailed migration details on the website. Again, really good to have a look at that and start doing your migrations, getting stuff onto Cedar and Graham from these machines. And getting used to the new machines, too. Just about Bugaboo. Bugaboo's coming up really soon. So the Bugaboo storage is going off support. SFU is going to purchase probably a significant number of nodes really early in the process, just so they can be added to Cedar right away and we can get all the Bugaboo folks moved over. So you'll hear shortly some of the details. The allocated groups, the storage will be migrated to Cedar over the next couple of months. You'll hear about that. So nothing to do right now, but keep an eye on things. And those who don't have allocations, you guys should be moving as soon as you can. So again, the aim is get you on Cedar. So start moving your jobs, your data onto Cedar. And I'll just note, as usual, there is the default. Everybody has access to Cedar. Just log in there, so our standard approaches with the RAS, the Rapid Allocation Service, the new name for the default, is there, and you can all get on it right away. Right. So those are a few quick notes there. The next one coming up is RAC, the RAC 2018. I don't know if most of you managed to get to the Compute Canada RAC presentation yesterday, given by Eduardo, the Compute Canada project manager in charge of RAC 2018. He aimed quite a lot at the fundamentals, the basic admin, how you fill in the forms, what the forms looks like. I've got a couple of little notes about that. But then we thought we might talk a little bit about best practices in working with RAC and submitting your proposals. So right away, a couple of the little details. Just the 2018 application forms are online. You can go and start doing your RACs. The deadline is November 16th, and there are the 2 competitions. The resources for research groups, RRG, that's the yearly, more job-based end, and the RPP, research platforms and portals. First thing, the fast track submission. So you should have received a fast track application or note if you were eligible for fast track, and you could just essentially click the button and say, yeah, I just want to use what I got last year, and we're off and running. So that's a nice thing. and I think it's quite a lot wider this year. So if you got that, great. Doesn't mean you have to do fast track if you've got farther along in your projects and you need more. Then you have to submit a RAC. So in the nature of sort of kind of best practices, I don't think some of this is new to you, and of course PIs are experienced in providing applications to funding agencies, so you know a lot of this kind of stuff, but thought I'd make it clear and just emphasize a few things. So a basic one is just that, Compute Canada is not able to satisfy all the demand. Last year, 58%, and the RAC applications are just continuing to go up every year. So this ends up being a competitive process. We've got some good news. I mentioned before, Niagara, the large parallel, expected to be up and going. Cedar and Graham Stage 2, the big expansion to Cedar, but we're losing a whole bunch of clusters. So in the end, I think next year we'll have something approximately the same number of cores as we've had previously. Now those are much faster cores, they're much more modern cores. We got lots more GPUs. So I think we'll end up with more, but I still expect this to be a really quite competitive process. A couple of details. Yeah, the fast tracks, so there are lots of fast tracks going out. I mentioned those. Notice of intents are not required this year. So if you remember, RPPs needed notice of intents last year. We're not doing that. I don't think that really added much to the process. You can delegate if you want to a sponsored user to work on the application. CCV is required for any of the full applications, but not for the fast track. But just as a general comment, CCVs, that's used by the science reviewers to look at the quality of the applicant. So it's a good idea to keep those CCVs updated. And some details about those CCVs. The issue is the second blue point there, that at the moment, CCV's got some technical issues with updating it, so you have to delete it and upload a new version. So if you are going to update a CCV, then go read those instructions. They're really important to figure out what you're doing. Yeah, I have to admit it's a little annoying just now, a little frustrating. Hopefully that'll get improved as the whole CCV operation. That's a separate system, and as we tie into it through Compute Canada. But right now, I have to work with what we've got. And then a bit more about Niagara. That's the big, large parallel system in Toronto. So we are allocating it. And the point I want to make about the RAC is that you should be aware that we are going to have something that's very large, very powerful, and aimed very much at large parallel jobs. I think it's going to be pretty flat. It'll be a whole bunch of equivalent cores. No GPUs, and I would think it'll have most, we don't know the details yet since they haven't been announced because it's still in negotiations with the vendor, but it'll be a pretty flat configuration. And as a bit of a rule of thumb, if you're using something like greater than 1,000 cores or so, that's probably a good thing to start thinking about using Niagara for. And if you got less than that, then Cedar and Graham are great. Just note the 1,000 cores just comes from the fact that both Cedar and Graham have 1,000 core islands with the interconnects. And so if you go more than 1,000 cores, you have to jump islands, and that'll add a little bit of latency. Doesn't mean that they can't do it. In fact, they can probably do it very well unless your code is very sensitive to latency. Plus large memory, and I'm guessing a bit at 4 gigabytes per core, but something like that. And then you have to go to the fat nodes on Cedar and Graham. So if you're writing the technical justification for a RAC, it'd be really good if you had things like scaling tests, performance tests, to show that your applications do scale to the kind of system that Niagara will provide. And anything special we have already had 1 or 2 requests for really significant proportions of cedar and graham. And essentially, we can't really give somebody 50% of cedar or graham right now. That's what Niagara is going to be aimed at, those users who really want very large parallel jobs. So anything like that, please emphasize it in your proposal and talk about it. That's new. Essentially, it's a new kind of big system for us, and we want to know if you can really use these. Yeah, so fun stuff there. Right, and then this business, going back to the competitive nature, I think it's been clear. Aaron and I have been working with the tech reviews for the last few years. We've read most of the applications at one point or another, and we've worked with the science reviewers. So these are kind of some ideas and suggestions, but we certainly have seen RAC proposals which look very lightweight and very quick effort. So this is a competitive operation. If you want these RAC resources, the Compute Canada resource, it's worth putting some effort into the proposal. And a particular point is read the CC docs, the evaluation criteria, and the proposal templates. Yeah, you should just follow those. We do get a few where they kind of go off sideways, and those are very hard to decipher and really don't get a high score. Just in the next couple of slides at the end of this, I'm just going to touch on a few of the basic best practices. Notice that the process ends up with a scaling function, which is dependent on the science score. So you can see from the graph last year, if you got a 5, a top score, perfect score, then you might have got 90% of what you asked for in the way of cores. And if you got about a 2.4 or something, 2.3, then you got nothing. So yeah, it's kind of competitive, and we try to work on this kind of scaling function. I should note that we do look, before we apply, say, a scaling function, at the technical justification to make sure that the original ask is reasonable. We do check to see if there are things like requirements that if we decrease it, then you're hooped, in which case we may just give you what you've asked for or almost what you've asked for. And storage is another one of those issues where, yeah, if you got a 100 terabyte database, we can't really only give you 50 terabytes. So we look at those quite individually. But everything depends on that science score. So it's very important in one's proposal to really emphasize the nature of the science, the quality of the science, the importance of the science, and then the justification to show that you really know how to implement what you're trying to do. So yeah, significance, impact of research, things like citation rates of recent work really are useful. And there at the bottom, a little comment that was on one of the proposals. So yeah, the motivation, what's to be learned, all those good things that are used by the science reviewers. Yeah, you need details. Again, we want to know. Tables are always good ideas. The more you can break down what you need, the more it's obvious to the both the science and technical reviewers, and the more it looks good, the more it looks well justified. Yeah, we had a couple of really long proposals. Yeah, they don't have to be super long, but you do have to cover all the bases. 1 or 2, let's see, major submissions. Yeah, sometimes you know, it looked like somebody had just lifted their NSERC. Yeah, of course you base what you do on some of the previous, your other submissions, but the RAC ones need to be focused on the resources you need, not on the funding. And it comes out. The 4th bullet point there, avoid jargon. Yeah, the reviewers are discipline experts. They're in there, but we don't have a expert in all the subdomains that our users, that our PIs come from. So you have to find a nice middle ground. You don't want to get right into the jargon and the details that are part of your specific project. But at the same time, you don't want to be too simple and not actually talk about the technologies you're going to use, somewhere in the middle. Yeah, and then, of course, edit, review, spend time on it. Another point, very quick, the highly qualified personnel, your students and such, sometimes this is looked at as a bit of a, an afterthought, that it's not that important. In fact, in some of the discussions I've been involved with, HQP really is discussed by the science reviewers. They really want to know that you've got some graduate students, that you know how to train them, that they're working on this project. Again, a nice table of grad students and what they're doing is really worthwhile. All that kind of thing in there, a couple of comments. And then, keep the CCV up to date. As you can see from those 2 comments, some proposals don't really tell us enough to know what's going on. Right, I'm kind of going through this fast. The slides will be available, but we want to get on to the GP4 stuff. This is a slide we've had before. So documentation on the new wiki, on the Compute Canada Docs wiki, and there are some videos, really nice stuff. So once you're getting started, go and look at these things. And the documentation wiki, it's under development. It's a wiki. So it's going to be always, in fact, these wikis are always being adjusted, modified as we learn more and change more. So keep having a look at this stuff and go back to them and see if there are any tricks that you can work on. For WestGrid explicitly, we've got a few training sessions organized. There, the 24th, there's the scheduling thing that I mentioned. ARC support on October 25th, classical molecular dynamics simulations, some nice stuff, containerization. So have a look at that, and I encourage everybody to attend these sessions if they look interesting. And then finally, for my end of things, we have a WestGrid or visualization challenge. The approach is that you're given a data set, and you see if you can develop some really, really pretty visualization. And I'm really like to thank Dell EMC, who have contributed a really nice 4K client, 4K monitor, a big monitor, as a prize for this. So, we got that, plus a few extra prizes, and you can get to the HPC Summer School. So good stuff. And again, if they got grad students who'd like to have a go at this and are interested in visualization, or undergrads for that matter, a small group who think they can really do a good job. It's not a what I'd call a seriously complicated data set, but we're looking for innovative solutions, hopefully that run on things like the GPUs. So have a look at the website. Right. At this point, I'm really pleased that Greg Newby, our Chief Technical Officer for Compute Canada, can join us. Greg joined Compute Canada a few years ago. He came from KAUST, the Saudi Arabia, the King Khalid University or supercomputer institution over there, and where he was leading, I think, the big Cray purchase. Before that, he was at the Alaska Supercomputing Center. So he came with lots of experience, and he's been essentially leading all these big purchases that we've just made over the last couple of years. And of course, really nice to see things like Cedar Graham come up. So, Greg, at this point, maybe I just hand over to you, and you can tell us a little bit about GP4. I think there were, a couple of slides there.
Yep. Can you hear me okay? Am I coming over?
You are coming over loud and clear, yeah.
Just a reminder, if everyone else who's not speaking can mute themselves, so we can cut down background noise.
Yeah, there's a little background noise there.
Yeah.
So I'm looking at the attendee list here, and many of the people are Compute Canada personnel, in other words, people that are in the project. And so I'm going to paste a link here. If you are in the Compute Canada domain or the WestGrid domain, there's actually a shared document where we've been keeping some input for GP4, and probably Aaron or someone was already thinking of taking notes on what people offer. But I wanted to paste that in there, and this is not going to work for people that don't have a Compute Canada login, but a lot of you do. So it's there. So what we're trying to do here is I'm going to give you a general overview. And part of what we're trying to do during the town hall is capture any input that you might have to guide future procurements but especially the GP4 procurement. And if you don't know what that is, that's part of what I'll talk about right now. So, so I think we have a few sort of overview slides, and then we'll get to a little more open, and you know, there can be Q&A or suggestions about GP4. So this first slide just gives a summary of where we're at, and as Patrick just characterized, boy, there's a lot going on, and it's such good news, and it's also very disruptive, and it's disruptive to the end users, it's disruptive to the various sysadmins and support personnel, and the only reason why we're willing to put up with the disruption is because the outcome is fast new gear, and we all like that too. So we're engaging in some pain, but we're also getting some benefits. And this slide sort of summarizes how much we've been doing over the last year and a half or so, and I know a lot of people on the call here have been benefiting from this equipment. So what's happening? Patrick gave a highlight of Niagara. That's going to be our next big system. They are forecasting that to be in production sometime in January. They might have sort of a shakedown cruise period of early users and so forth, but they do still commit to having that Niagara system available in time for the RAC. So that's all good. And then we have some other activity on, which I think Patrick already highlighted. So let's go on to the next slide, and we'll focus on GP4 a little bit. Now let me preface this by saying that this is in a weird state of confidentiality. And so you'll notice that these slides do not say where GP4 will be. And in fact, we probably are pushing our luck just a little bit having this much disclosure on GP4. And the reason is that CFI, Canada Foundation for Innovation, has not yet announced the outcomes of Stage 2. So here we are in the WestGrid Town Hall, and we've done other forums where we are saying, you know, here's what's going on with CEDAR, here's what's going on with the storage expansion, and here's what's going on with GP4. Now, the proposals that Compute Canada wrote and submitted from last May are public. They're actually in the computecanada.ca publications area, but the outcome is for CFI to announce, so they haven't done it yet. So, so just among us, but not for the slides, we do know the site, as you might imagine, is going to be in a new province, or a province that's not currently hosting. So it's not going to be another BC site, or for those of you that were hoping for that, and it's not going to be in Ontario either. And we should be able to announce this more comfortably after CFI makes their announcement, and I'm very much hoping that's going to be this fall. And there's a lot of reasons why it probably will be, but it hasn't happened yet. Now, I would have been willing to say the site to all of you, my dear friends, if this wasn't being recorded for anonymous streaming on the internet. So what CFI has asked us not to do is just to sort of broadcast or publicize the information. But if you're really curious about what the site is, then ask Patrick or Aaron or someone. And it's okay for any of the analysts, any of the people that know to tell you. It's not okay for us to put it up for public announcements, because CFI will treat that as an announcement. Okay, so a long digression there just to say why we're being a little bit cagey about the details. But that said, we know how much it's going to cost. We know about how much storage we're anticipating, and we know, because it's a GP system, we know about the types of configuration. And what this basically means is it's going to be similar to Graham and Cedar. You know, a bunch of different node types, to be determined the detail, but a bunch of different node types favoring jobs of up to around 1,000 cores, 1024, 1280, or some type of number like that, like Cedar and Graham. And you know, really be workhorse systems, just like Cedar and Graham. Among other things, some of the people on the call are probably involved with proposals to CFI and the tri-councils. And with CFI in particular, sometimes you end up with a contributed system or a Compute Canada condition situation where you have to add, you're asked to at least consider adding your new system, your new nodes, to an existing system. Well, the existing systems that are getting most of these are the GP systems, Cedar, Graham, and the new GP4 system. So these are going to be important for a lot of different types of research. Okay, let's we can go on to the next slide. I guess the only highlight on the slide we're just looking at is the system. Some of you might have noticed a $17-ish million price tag. This will actually be the biggest dollar amount of any system, including Niagara, through the Stage 1 and Stage 2 program. So it's going to be a hefty size system. Depending on our choice of node types, it'll probably be about the same size as the upgraded Cedar, because Cedar was about a $10 million system. We're doing about a $7 or $8 million upgrade on it. And GP4 will be about that same total, about $17 million when it's born. So, really, really big systems, but systems that serve a diversity of needs, which is part of why we're talking about this. Okay, so on the next slide, it mentions feedback. And this is not intended to be exhaustive, but it's to get the mental juices flowing. And we appreciate this feedback anytime, any way you want to get it to us. Doesn't matter. It doesn't matter if there's tables and numbers. Doesn't matter if it's just a question or a suggestion. All input is good. As I pasted before, we have a shared document that the analysts can use to to paste stuff into. You could email, if you want to email cto@computecanada.ca. I can receive information that way. Or email Patrick or anything like that. And it's great to aggregate stuff, and it's great to have like well-considered, balanced, like white paper type of things, but that's not necessary. Any input is welcome. So here are some of the things we're asking ourselves about. Oh, by the way, I see my picture is faded to black. I'm still here, obviously. You're still hearing me. But yeah, so this is what happens, by the way. We use video a lot in Compute Canada, and I upgraded my Macintosh to High Sierra. And every time you do an OS upgrade, in my experience, something in video stops working, and until they fix the client. And in this case, it seems to be the camera. That is, it works until I start talking, and then it goes away. Anyway, so here's a listing of potential stuff, and basically, the question is, what should be the node configuration or node mix? And is there anything that we are not yet able to do on Cedar and Graham that we could design into GP4? So what that means is, and some people are more familiar than others with what we have on Cedar and Graham, what that means is we want to take what we've done and adjust as needed. So if you look at Cedar and Graham, these are systems that have about 7 different computational node types. In addition to like some management nodes and some sort of utility types of things. They also have 2 networks. They have an InfiniBand network or an OmniPath network for Graham and Cedar respectively. And they also have a 10 gigabit network, which we can use for the cloud partition. These nodes also, every single one has local storage. And the local storage is on the order of a couple terabytes. And it has slightly different configurations on Cedar and Graham, and the Arbutus cloud out in UVic also has local node type storage. And so part of the question is, well, do we always need local storage, or never need local storage, or do we need more local storage or less local storage? Because local storage actually, you think of it in terms of what you get for your dollar, and the local storage adds maybe 10 or 15% to the cost of the node that we can instead use for other nodes. So these are the types of considerations. In those 7 node types on Cedar and Graham, we have GPU node types, we have CPU node types. We'll probably get some of each for GP4, but do we need the same amount of memory per core approximately, or should we consider more memory or less memory in some nodes? Would that be suitable for your workload? And then on the GPU side, I think the people that use GPUs know what a incredibly diverse and somewhat confusing and also, by the way, really expensive ecosystem makes up GPUs these days. And so we're saying, okay, we got the new Volta GPUs coming out. They're going to be more expensive than the new Pascal GPUs, and they're also a lot more expensive than the gamer-style GPUs. What would be a good mix to get in these nodes? And is 4 GPUs per node a good number, or is 2 a better number? And by the way, Graham has mostly 2 GPUs per node. Cedar has mostly 4 GPUs per node. So these types of questions. So all of these questions about like how well suited is the node configuration for your needs. I'll mention one additional really specific one because we have some Bugaboo users that are wondering what's going to happen when they don't have a 16 terabyte system. And the short answer is, well, we got some 3 terabyte nodes on Cedar and Graham, and you can have a whole entire node with I can't remember, I think it's 24 CPU cores, and get yourself 3 terabytes of memory. And so the question is that enough? And if you're on Bugaboo and you really have a need for 8 terabyte computation, you're going to be without a place to compute that size of memory, a single memory node. So what are we going to do about that? And the answer is, if you have a reasonably well justified need to go beyond the 3 terabytes, or maybe we'll end up with 6 terabyte nodes because of memory sizes on GP4, well, timing is great to tell us about that need. Okay, I think a lot of the rest of this is more on the configuration implementation side, and those are always open for discussion. And in fact, as Patrick mentioned before, the systems are designed for jobs. Cedar and Graham are designed for jobs of up to around 1,000 cores. But in practice, your analysts, your support team, can do a whole lot to make jobs run that are bigger or longer running, or all kinds of crazy stuff that we get asked for. And we always try to do our best. So there's flexibility in there, but there's also sort of the basic default approach. And I think this is an opportunity for GP4 to mention anything that might not be totally well aligned with how you want to work. I mean, and almost anything is on the table there. But I want to highlight that we can actually do a lot of stuff on Cedar and Graham too. So if you're finding that there are challenges getting your work done, there's no guarantees that everything you need can be delivered, but certainly you should make your needs known. Okay, I think I'll stop talking now and see if there are questions or comments of any type. I think we're pretty open to whatever people want to say. And also, actually, maybe we should just see if Patrick or any of the analysts have specific things to augment what I was just talking about, because I might have missed some of the relevant points.
Yeah, thanks, Greg. Yeah, I think that's a great overview. And no, I think that covers pretty much everything. And we've got a few minutes, so that's kind of perfect. So I think it's kind of open to the floor right now. Has anybody got anything that they are really interested in the way of what GP4 might look like? Any questions out there? I think everybody can just break in, right? Aaron, the mics are enabled, so.
Yeah, everyone's unmuted.
Yeah. So kind of all sounds good. We've just recently had some big discussions about the GPUs, and we're really wondering. Greg mentioned the Voltas, but they're expensive. Maybe more focused on the machine learning end of things, and then the other end of the scale is the gamer ends, really cheap. But there are some issues with warranties and support when you stick a non-enterprise class system or GPU on a node. And we're seeing that it's the molecular dynamics end who are using most of the GPUs now. In fact, the GPUs are heavily used, but not necessarily really highly efficiently. Anybody doing that right now? Is anybody using GPUs on Cedar right now? Anybody in the audience? No, not really. Okay.
Well, we have a few comments, or Aaron typed in a comment there. Let me mention one thing that you might be interested in is what we might call workload portability and diverse workflows. And this is an area where getting use cases from people that are using the systems is very valuable. So in particular, when I'm talking about workload portability, I mean, well, maybe you want to submit a job and have it run kind of wherever, run on Cedar or Graham or GP4. And we're trying to design this in, and it's intended basically to improve time to solution. In other words, your job finishes sooner. Workflow is an interesting topic because we know that there are people that have sometimes worked really hard over a period of years to get a whole flow of processing, from pre-processing through some, batch big jobs, through some post-processing and visualization, and maybe some data are going out to like a portal, cloud type of host, web type of host. And so we want to support that. And so knowing more about your needs for, sort of flexible workflows would be interesting. So I just want to mention those two things as something that we are working on. And I think what I'll do is I'll stop and I'll count to at least 10 quietly, and we'll see if anyone has anything to speak up. And if not, we'll probably be done, and we'll be happy to get other input later.
I just the question that Aaron put up about some issues with connectivity through Canary and Cybera. Yeah, that's an interesting question. I don't think I've heard before that people are having issues getting data. I think I wouldn't mind following up. I'm not quite sure who did that, but if you want to give me an email or send a note to support@westgrid.ca, I can have a look at it and see what. Yeah, thanks, because that's that's a little bit of a new one, and of course we are completely reliant on Canary for the national backbone, and the ORANs like Cybera for the local connections, the provincial connections.
So just to comment on that, as far as I know, Cedar is connected to Canary with 100 gigabits per second. So I very much suspect that the bottleneck is at the other end.
Yeah, could be. Yep.
Came from a University of Westbridge user.
Yeah, so it's probably at the Lethbridge end.
Yeah, might be. Yeah. Okay.
A great tool that that enables transfer, what they call third-party transfer, which would be from like a really fast connected system like Cedar to another really fast connected system, which might be, in the case of this, maybe it's the Canary Dare Cloud out at Sherbrooke or something like that, and that's Globus. So using Globus to transfer files is usually the first recommendation to split transfer up. But part of that is not to loop it through like your, I think people know this, you don't loop it through like your laptop on your home DSL connection, but you also don't loop it through your campus, because your campus, if the data don't need to stay on your campus, then you do a third-party transfer.
Yeah, cool. And I see Barton Satchwell from Cybera, is online. So we might just discuss this offline maybe a little bit and see. Yep. Okay, well, if there are no questions, I think we'll really encourage anybody to send us notes. To the internal folks can go directly to the Google Doc. But otherwise, send them to me. Any comments you've got, any suggestions. Probably we should get them within the next couple of weeks, because the site is looking at, and the team is really looking at the RFPs and how they're going to write the RFPs sort of as we speak. So we don't have a huge long time to get some input into that site. Otherwise, I think, there's the usual final slide. Support at WestGrid. Look at the docs, and there we are. Thanks, everybody. That's great.
One more question coming in.
There is one.
Hungary. Large shared memory computations.
Yeah. I mean, this is so let's it's good. Let's recap where we're at. Is when we analyzed Hungary, which was about a year and a half ago now, we looked at the job sizes that were run on Hungary, and most jobs were well under half system, 8 terabytes. Very few jobs were 16 terabytes, and there were a lot of jobs that were doing pretty well with more on the order of a terabyte or so. And if you look back in history, terabyte a single system was bigger than we had anywhere else in Compute Canada. So it's really timely for us to know what research areas need to scale, beyond, say, 3 or 6 terabytes. Because what happens is, these days you can buy a single node. Like you could all, if you had the money, you could all go out and buy a node for about $70,000 or $100,000 that has 3 or 5 or 6 terabytes of memory. Beyond that, you get into a more specialized type of system. In fact, SGI is still doing these ultraviolet type systems. So we really need to know about the science that must have more than call it 3 or maybe call it 3 or 6 terabytes. And it sounds like there's stuff out there that that we could use. And don't wait for RAC or something to send in a nice, well-reasoned proposal with all the tables and stuff that Patrick was talking about, because it might not be as impactful as getting it to us earlier.
Yeah. So Aaron, if you can send me, and I can follow up too. Yeah.
And just
Yeah,
to
like
add to that, we have, as Greg mentioned, the 3 terabyte nodes on Cedar and Graham. What we are seeing, though, is that those large memory nodes are basically not used, as if there's absolutely no demand for nodes with very large amounts of memory. So if you are a user who has really a need for large memory nodes, you must let us know. Otherwise, the indications, the usage indications that we are getting right now is that there's no demand for large memory nodes. And we are not going to, if that remains that way, we are not going to purchase more of these because they're really expensive.
Yeah, good point, Martin. Yep. So yes, get in touch with us. Okay. I think we are done at that. Good.
All right. Thanks,
See you, everybody. Thanks very much, and thanks a lot, Greg, for joining in.
My pleasure. Bye-bye.